Today we're going to talk about functions and their graphs. The objective is to find the domain and range of a function, the range of a relation, determine whether or not a relation is a function, determine whether an equation represents a function, evaluate a function, graph functions by plotting points, use the vertical line test to identify functions, obtain information about a function from its graph, identify the domain and range of a function from its graph, and identify intercepts from a function's graph. So first let's talk about how to find the domain and range of a relation. A relation is any set of ordered pairs. The set of the first components of the ordered pairs is called the domain, and the set of second components is called the range. So, get my pen out just a second. So if you have the ordered pair x, y, the x is your domain, the y is your range. So we're going to find the domain and range of this relation. So let's look at the domain. As I stated earlier, the domain will be all of your x values. So it will be 0, 10, 20, 30, 40. Okay, the range will be all of the y values. So that would be 9.1, 6.7, 10.7, 13.2, 21.2. All right. So now we're going to determine whether or not a relation is a function. A function is a correspondence from the first set, called the domain, to the second set, called the range, such that each element in the domain corresponds to exactly one element in the range. So in other words, an element in the domain cannot repeat itself. Okay? An element in the domain cannot repeat itself. Okay? If it does repeat, the relation is not a function. All right, so let's look at this first one. First, let's figure out the domain. Remember, the domain will be all of the x values. So we got 1, 3, 6, and 8. As you can see, none of these values repeat. No elements repeat. So this is a function. All right, let's look at the domain for the second problem. We have -2, -3, -2, -5. As you can see, the -2 repeats. So this is not a function. The elements in the domain cannot repeat. Alright, so I have a U-try problem on here, and I will tell you that it's not a function. You can go ahead and figure that out on your own. Now let's determine whether or not an equation represents a function. If an equation is solved for y and more than one value of y can be obtained for a given x, then the equation does not define y as a function of x. So we're going to determine whether or not this equation defines y as a function of x. We have x squared plus y squared is equal to 1. So the first thing I'm going to do is I'm going to solve for y. The first thing I'm going to do is subtract x squared from both sides. This gives me y squared equal to 1 minus x squared. To get y by itself, I'm going to take the square root. Now remember, when you take the square root over here on the right hand side, you get a plus or minus when you take the square root. So that means this plus negative shows that for certain values of x, there will be two values for y. Okay, so in other words, you'll get two answers. Anytime you substitute a number in for x, you're going to get two answers for y. So for example, I'm just making this up, you might get negative x and, negative 8 and 8. So you'll get two answers. So in order for it to be a function, you can only get one answer for y when you plug in an x. So this is not a function. Not a function. And that's because of that plus minus. If you look at this next problem, we have x plus y is equal to negative 3. We're going to go ahead and get y by itself, so I'll subtract x from both sides. I get y is equal to negative 3 minus x. So in this problem, if we plug in a number for x, we're going to get one number for y. So for example, if you plug in x is equal to 1, your y is going to be equal to negative 4. So any value you put in for x will return one value for y. So this will be a function. Okay, and this next problem is a U-try problem. You can go ahead and solve this on your own. The answer will be not a function. Alright, so now let's talk about how to evaluate the function. So when you see this special notation, f with x in parentheses, it's read f of x or f at x. It represents the value of the function at the number x. It does not mean f times x. A lot of people get that mixed up. It does not mean f times x. So we're going to look at this function, f of x is equal to x squared minus 2x plus 7. We want to evaluate it at f of negative 5. So in other words, when x is equal to negative 5, what is this function equal to? So whenever we see an x, I'm going to plug in negative 5. And then I'm going to solve the right hand side. I get 25 plus 10 plus 7, and that is equal to 42. So when x is equal to negative 5, your function is equal to 42. You can think of f of x is equal to y. When you plug in a number for x, you solve for y. Basically, that's what it is. In this next problem, we have f of x is equal to 2x squared minus 5x plus 1. We want to evaluate it when x is 3. So whenever we see an x, I'm going to plug in 3. I get 2 times 9 minus 15 plus 1. 2 times 9 is 18 minus 15 plus 1 is 4. So when x is 3, this function is equal to 4. I have a U-try problem here. You can go ahead and solve this on your own. You get an answer of 23. The next part talks about the graphs of a function, and it's just what you do is you just plot its ordered pairs. So we're going to graph two functions. We have f of x is equal to 2x and g of x is equal to 2x minus 3. We're going to graph them on the same graph, and we're going to select values for x from negative 2 to 2, ending with 2. So let's graph the first one. F of x is 2. So I'm going to make a table. Remember I said f of x or any function is just the same as y. I'm going to go from negative 2 all the way to 2. So when I plug negative 2 in here, negative 2 times negative 2, 2 times negative 2 is negative 4. When I plug in negative 1, 2 times negative 1 is negative 2. When I plug in 0, I get 0. And when I plug in 1, 2 times 1 is 2. And when I plug in 2, I get 4. Okay? So now I'm going to do the g of x. G of x is 2x minus 3. Once again, I'm going to go from negative 2, negative 1, 0, 1, 2. So when I plug in -2 back into the function, I end up with -4 minus 3, which is -7. When I plug in -1, I get -2 minus 3, which is -5. When I plug in 0, I get a -3. When I plug in 1, 2 times 1 is 2 minus 3 is -1. And then when I plug in 2, you get 4 minus 3, which is 1. So each one of these will be your ordered pair. So that's what we're going to graph. We're going to graph each one of these ordered pairs. So the first graph I'm going to do will be the y is equal to 2x. Let's go ahead and plot -2, -4. You go to -2 down to -4. Then you go to -1 down to -2. 0, 0 is at the origin. Then you have 1, 2, and then you have 2, 4. As you can see, your points go into a straight line. I'm sorry if my line is crooked because I really can't draw freehand like this. So this is your graph. This is for f of x. Now let's go ahead and draw g of x. I'll do that in a different color. We're going to plot -2, 7. So we go across -2 down to -7. Then we got -1, -5. Then we got 0, -3. Then we got 1, -1. And we got 2, 1. And we'll go ahead and draw the graph. Like I said, I really can't draw very well on here, but it's supposed to be a straight line. And this is for the graph g of x. Okay, my line is very crooked. I tried. If you do this on paper, of course, you'll have a ruler, so you can draw it better than I can. I don't have a ruler on this computer screen. Alright, so now we're going to talk about how to use the vertical line test to identify functions. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So let's do a problem. Let's say you have this U-shaped graph. If I were to draw a vertical line anywhere on this graph, if I draw it here, 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 as you can see, it touches the line, this graph, only once. So this would be a function because when you draw a vertical line, it only hits the graph once. So this is a function. Vertical line hits the graph once. Okay. If I have another graph, let's say I have this graph. So if I draw a vertical line here, let's say I draw a vertical line here. So yes, it hits the graph once here, but if I draw a vertical line here, as you can see, it hits the graph 3 times. So the vertical line has to hit the graph once anywhere you draw it on that graph. So in this case, this is not a function. The vertical line hits the graph more than once. Alright, so now we're going to talk about how to get information about a function from its graph. In this particular problem, this talks about T cell count and HIV infection. So it looks like your T cell count is high when you're first infected with HIV. You're likely at the asymptomatic stage, so you don't have any symptoms. However, as time progresses and the HIV is messing with the body, your T cell count goes down. So this horizontal axis talks about time after infection. So let's say you're at 11 years after you got infected with HIV. As you can see, your T cell count is very low. Whereas in the beginning, when you first get infected, your T cell count is still pretty high, but as you can see, it decreases. Alright, so in this problem, we're going to figure out some information. We're going to find f of 5. we want to know what is your T cell count after 5 years. Okay, so that's f of 5. So if we look at this graph, if we go to 5, if we go up to the graph and go over, we get 400. So after 5 years, your T cell count is at 400 millimeters. The next part asks, what is the value of x when f of x is equal to 100? So basically, your y is equal to 100. So if you go to this graph, this is the y, your 100 is here. So to figure out the x that corresponds to it, you're going to go over till you hit the graph, and then you go down. So it looks like the answer would be 9. Okay, so you can get different types of information from the graph depending on what the question is being asked. So now we're going to talk about how to find the domain of a function and the range from a graph. The domain will be the inputs on the x-axis, and for the range it will be the outputs on the y-axis. So if you look at this graph, this first graph, your domain is what you see along the x. Your range is what you see along the y. Okay? So you only look at the specific graph. So I got dots on these graphs, meaning that these points are included. So if I were to list these ordered pairs, this point here would be -2, 0. The next one would be 0, 2, and the next one would be 1, 3. All I'm doing is finding these ordered pairs for these dots. So if we look at the domain, we're only looking at the x value. So we got -2, 0, and 1. Okay, so your domain goes from -2, which what I have right here, and it goes to 1 on the x. And that's what we have here. It goes from -2 to 1. But we're going to write this in interval notation. So it goes from -2 to 1. We're going to put these in brackets because that we have closed circles on these graphs. So that indicates that these values are included. Now, if you were to look at the range, remember the range would be the y values. So we got 0, 2, 3. All right, so if we write this in interval notation, let's look at this graph. The range goes on along the y. Remember, the y goes up and down. So it goes from 0 up to 3. 0 up to 3. Okay, so in interval notation, that would be bracket 0 to 3. All right, so let's look at this graph here. As you can see, we have an open circle. With this open circle, that means that this ordered pair or this value is not included. But we're still going to include it, but we're going to have to write it differently when we write the interval notation. So let's look at these points. We got this point here, which is -2, 2. And we also got this point over here. So I'm just going from this point to this point. Those are my ends. So the next point would be 1, -1. So if we were to look at the domain, remember the domain would be the x's. We got -2 and 1. So the interval notation would be parentheses -2, 1 bracket. The reason why I have parentheses is because this -2 is not included because it's an open circle. So when you have open circle, you put parentheses. If you have closed circles, you put brackets. So this goes from -2 to 1. Okay? Now the reason why I didn't write out the full domain like you have this point here as well, 0, 0. For this purpose, I'm only looking at the interval notation. So from -2 to 1 will include all of this in here. So it'll include this 0 here. So that's why I didn't write out the whole domain in here. Okay? So if you think about it, it goes from, on your x, it goes from here to here, which is from -2 to 1. -2 is not included. So now if we look at the range, remember it goes you look at the y outputs. Okay, so if we look at the interval notation for this, the y will go from here up to here, from this point here to this point here. All right, so it looks like it goes from -1, which is included, so we're going to put a bracket, all the way up to 2, which is not included. Okay, so it goes from here to here. So now let's look at another graph. This one is a U shape. This U shape, as you can see, we have arrows. So that means that this graph keeps going, going out. Same over here. Keeps going and going and going and going and going. So along the X, it never stops because this keeps going all the way out. And we don't know where it stops. All we know, it just keeps going. So for your domain, going along the X, it goes from -infinity to infinity. Okay? It does not stop based off this with those arrows here. For the range, remember, we go up and down. So it looks like it starts right here at the origin, which is 0. But since it keeps going out and out and out and out and out, it goes all the way out into infinity. For infinities, you always use parentheses. For this next problem, I have little dots here. These are closed circles. So that indicates to me that this is where this graph stops. So let's look at the domain. We're going to look at it along the x-axis. So from here to here is my graph from the x. From here to here is my graph from the x. So it looks like it goes from -3 to 4 along the x, if you got to count the little points. For the range, it goes up and down. So for the range, it looks like it starts at the origin, but it stops here where these where the circles stop. You can count 1, 2, 3, 4, 5. So it looks like it stops here. Okay? Because it's closed circle. So your range looks like it goes from 0 all the way up to 5 along the y. Next, we're going to talk about how to identify intercepts from a graph. For the x-intercepts, you look at the points at which the graph crosses the x-axis. Your x-intercepts are always written as a0. For the y-intercept, you look for the point at which the graph crosses the y-axis. For the y-intercepts, your point will always be 0b. You can have more than one x-intercept, but at most one y-intercept. So let's look at the x-intercepts. This is my x-axis, and I have the red dots. That's where your graph crosses the x-axis. So we have -3, 0, -1, 0, and 2, 0. For the y-intercept, I got this blue dot here. This would be 0, -6. I have a U-try problem here. I'll go ahead and put the answers up and you can try this on your own. The x-intercept is 3, 0 and the y-intercept is 0, 6. That's the end of this video.